All right, today we're going to pull back the curtain on a little piece of everyday magic. How exactly does AI understand images?
So think about this for a second. You type cat into your phone's photo library and bam, every picture you've ever taken of your furry little menace pops up. How does it do that? It feels like straight up wizardry, right? Well, it's not. It's actually a super fascinating corner of AI, and we're going to break down exactly how it works.
So here's what we're going to cover. First, we'll look at how computers even begin to see. Then, how they turn those pictures into numbers they can actually search. We'll touch on a super important AI model, the transformer, see how the matching actually happens, and then, we'll put it all together. Okay, so first things first. How in the world do computers see an image? I mean, the whole idea here is to build an AI that can process visuals kind of like our own brains do. And the main character in this story, it's something called a convolutional neural network, or CNN for short. Seriously, just think of it as an artificial brain that's been specifically designed for one job, vision. It's totally inspired by how our own visual cortex works. Yeah, this diagram really nails it. See, a CNN doesn't just look at a photo and go, oh, that's a car. No way. It starts with the absolute basics, tiny little pixels, lines, and edges. Then, layer by layer, it starts putting those simple pieces together into more complex things, like a wheel or a window or a door. It just keeps building up until it gets the whole picture. It's like a pyramid, starting with simple patterns and ending with a really complex idea. And what that means is that this whole layered approach makes CNNs ridiculously powerful. They don't just recognize what's in a picture, they can tell you where an object is, they can cut it out from the background, and, this is the big one for us today, they can find other pictures that look just like it. I mean, this is the exact same tech that lets a self-driving car spot a person crossing the street or helps a doctor find a tumor on a scan. It's a huge deal. Okay, but just knowing what's in an image, that's only half the battle. If you want to search through millions of them in a split second, you've got to translate them into a language a computer can actually compare. And that means we need to turn pictures into numbers. And that whole translation process, it's called image embedding. What's happening is the CNN takes an image, looks at all those important visual things it's learned, and boils it all down into a long string of numbers. We call that string a vector. And you can just think of that vector as a unique numerical fingerprint for that one specific image. And right here, this is it in action. A picture of the sun, a banana, a castle. Each one gets crunched down into its own special numerical vector. Every single number in that string stands for some visual feature the AI picked up on. Things like how round is it? How yellow is it? Or does it have pointy bits? This might sound kind of weird and abstract, but if you think about it, every digital image is already just a bunch of numbers, right? It's just a big grid of pixels, and each pixel has a number for how much red, green, and blue light it has. So what an embedding is doing isn't magic. It's just creating a way smarter and more compact summary of all that numerical data. And this is the secret sauce to the whole thing. The way these embeddings are made means that pictures that look alike end up with number fingerprints that are really similar. So, two different photos of your cat, their vectors are going to be practically neighbors in the mathematical world. So, CNNs are awesome at seeing the what in a picture. They can spot a cat, a car, a tree. But what about the story? What about the relationships between things? For that deeper level of understanding, AI needed a new trick up its sleeve. And that trick was the transformer. Transformers first blew up in the world of language because of their killer feature, something called self-attention. It's basically a way for the model to figure out which parts of the input are the most important. So in a sentence, it knows which words relate to each other. When you apply that to an image, it can learn that the dog is related to the ball it's chasing, and that those two things are way more important than the random tree in the background. It gets the context. Okay, I know this diagram looks a little intimidating, but just follow the basic path with me. The image gets chopped up into little pieces and fed in on the left. It goes through these encoder layers, and the real magic happens inside those boxes labeled multi-head attention. You can think of it like this. The AI is looking at every single part of the image at once. A dog over here, a ball over there, and it's constantly asking, hey, how does this piece relate to that piece? It's not just seeing objects in isolation, it's building a whole relationship map to understand the scene. That's how it gets that incredible sense of context.
And the cool thing is, you don't even have to pick one or the other. In fact, the most powerful systems out there today are hybrids. They use a CNN for what it does best, pulling out all those raw visual details, and then they pipe that info into a transformer to figure out the big picture and the story. It's truly the best of both worlds. Okay, so we've got our numerical fingerprints for every image. Awesome. But now what? How does the computer actually dig through millions of these things to find the one you want? Well, that is the art of the match. It all comes down to something called a similarity search. And that's just a fancy name for an algorithm that takes the number fingerprint of your search image and then compares it to all the other fingerprints in the database to see which ones are the closest mathematically.
So how does it measure closeness? Well, a really popular way is called cosine similarity. Just picture each of those number fingerprints as an arrow shooting out from the center of a globe. Instead of measuring how far apart the tips of the arrows are, this method measures the angle between them. So if two images are super similar, their arrows are going to point in almost the exact same direction, right? The angle between them will be tiny. A 0-degree angle, that's a perfect match.
All right, we've laid out all the key ingredients. Let's head into our final section and see how all these pieces click together to make the whole system work.
So the official technical name for all this is content-based image retrieval, or CBIR. And that content-based part is everything. It means the system isn't looking at file names or tags that a human typed in. No, it's searching based on the actual visual stuff inside the pictures themselves. So here it is, the whole process from start to finish. 1. You give it an image to search for. 2. That image gets fed into a CNN, which spits out its unique numerical fingerprint, that embedding we talked about. 3. The system calculates the similarity, comparing that fingerprint to every single other one in the database. It ranks them all based on how close they are, and then boom, the images with the highest scores, the closest matches, pop up on your screen. And that, my friends, is how your phone finds every last picture of your cat.
And this leads to a really mind-bending idea. We've just talked about how AI learns to understand images by turning them into these numerical embeddings, but this is not a one-way street. This is the very same technology that makes generative AI work. To create a picture of a cat from scratch, the AI first has to understand that catness vector. So think about it. If an AI can get this good at understanding what an image is, what are the limits on what it will be able to create? It's something to chew on. Thanks for tuning in.